Hello Space Cats and welcome back to my channel. In this week's video I'm going to be talking about the moon and more specifically what is on the far side of the moon. So let's do this. It's not uncommon that I hear the phrase dark side of the moon, and no, Pink Floyd did not help. This phrase is very, very wrong. There is no dark side of the moon. All sides of the moon at some point are illuminated by the sun. But generally, I don't call people out on it. I know what they really mean. The far side of the moon, of course. The moon is tidally locked to the Earth. So we will always see the same side with a little bit of a wobble. If you look carefully, you will also notice that it appears to grow and shrink. This is because the moon orbits the Earth in a slightly elliptical orbit and not a spherical one. Its distance to the Earth can vary by up to 10%. When the moon is closer, the Earth's gravity is pulling harder and therefore we get a wobble. This is also when the moon appears slightly larger. When we see half a moon, half of our side is illuminated and half of the far side is illuminated. So none of it is completely in darkness at all. Just like on the near side of the moon, the far side of the moon is covered in moon dust, which is highly abrasive. When astronauts went to the moon, they came back with very worn out, cut up boots. And this is because the dust is razor sharp. But unlike on the near side of the moon, the far side of the moon is very heavily cratered. Originally, people thought that this was because the Earth acted like a shield for the moon, shielding the near side from asteroids and other debris, and similarly that the far side of the moon took the brunt hit of asteroids from the Earth. While this might be partially true, the area that the Earth obscures, as seen from the moon, is tiny. If you count the number of craters, there is no way it can account for all of them. It's more likely due to the fact that the near side of the moon has a thinner crust, which at one point would have allowed lava flows to fill up all of the craters. The moon has no atmosphere to regulate the temperature like we have here on Earth. So in the sunlight, the surface can reach over 100 degrees Celsius, whilst in the shade it can be less than 100 degrees Celsius. If water exists on the moon, it would be completely evaporated upon illumination by the sun. However, more craters means more opportunity for water ice to exist, because scientists think that water ice could remain on the surface in permanently shadowed crater regions. Typically, these exist in the polar regions. And water is not only just a biomarker for life, but in this case is very important for advancement of space travel. Water is expensive to transport into space. Each kilogram costs almost $20,000 delivery charge. But if we can find water in space, then we can use it to make oxygen and hydrogen fuel cells. To date, no one has ever set foot on the far side of the moon. The huge amount of craters would make landing very, very difficult. And this is one of the main considerations for choosing landing sites on other celestial bodies, like even Mars too. But that's not the only thing. When you're at the far side of the moon blocks out any radio signals to the Earth. So you wouldn't be able to communicate with anyone on Earth. This actually happened to the Apollo 8 astronauts. As they orbited the moon, they were the first people to see the far side of the moon. But they were cut off communications by 10 whole minutes.
We believe that Mike Collins is now maneuvering the spacecraft in the transposition and docking maneuver, and the antenna patterns aren't too good at the moment. So we have a weak signal strength.
In 2019, CNSA, the Chinese Space Agency, became the first and the only to date to successfully land a spacecraft and rover on the far side of the moon. They named it Chang'e 4. Since direct communication with the Earth is impossible, this mission was made possible only because a year earlier, the Chinese sent a satellite to a stable point behind the moon, the Earth-Moon L2 point. This satellite then was able to relay communication commands back and forth between the Earth and the rover and lander. There is still so much potential for exploration on the far side of the moon. There's still so much to learn about. The radio silence on the far side would also make for the perfect location to install radio telescopes for astronomers. It'll be interesting to see what the future holds with the far side of the moon. I hope you enjoyed this week's video. I'll be back again soon, but in the meanwhile, if you enjoyed the video, please don't forget to leave me a like, share and subscribe.